In section 7.3, we have systems of nonlinear equations and inequalities within two variables. Now, there are possible types of solutions for points of intersection of a parabola and a line. Figure 2 illustrates possible solution sets for a system of equations involving a parabola and a line. We have no solution, so the line will never intersect the parabola. Then we have one solution, where the line is tangent to the parabola and intersects the parabola at exactly one point. And then we have two solutions, where the line crosses on the inside of the parabola and intersects the parabola at 2 points. Now, if we're given a system of equations containing a line and a parabola, we want to be able to find the solution. Number one, we're going to solve the linear equation for one of the variables. Number two, we're going to substitute the expression obtained in step 1 into the parabola equation. Number 3, we're going to solve for the remaining variable. And number 4, we're going to check your solutions in both equations. So in example 1, we're solving a system of nonlinear equations representing a parabola and a line. So we have equations 1 and equation 2. Equation 1 is x minus y, which is equal to negative 1. Equation 2 is y, which is equal to x squared plus 1. So we're going to solve the first equation for x and then substitute the resulting expression into the second equation. So for the first equation, we have x minus y equals negative 1. And then in order to solve for x, we're going to add y to both sides. So we get x, which is equal to y minus 1. And so then what we can do now is we can substitute the expression that we got for x into equation number 2. Equation number 2 is y is equal to x squared plus 1. And we're going to substitute x to be y minus 1. And then we're going to have to square it and then add 1. Now we're going to have to expand this equation and set it equal to 0. So on the left side, we still have y. And we have y minus 1 squared. So that means we need to expand that by FOILing that out. When we FOIL that out, we get y squared minus 2y plus 1. And then we're adding the 1 on the outside here. And so now we're going to subtract y to both sides and then add 1 plus 1. So we end up getting y squared minus 3y plus 2, and that's equal to 0. And now that we have a quadratic equation, we can then factor. So we have positive 2 and negative 3, and the two numbers that we can multiply to get positive 2 and add to get negative 3 are negative 1 and negative 2. So we factored this to be y minus 1 times y minus 2 equals 0. Solving for y, we get y is equal to 1 here. And solving for y here, we get y is equal to 2. So solving for y gives us y is equal to 2 and y is equal to 1. And next, we're going to substitute each value for y into the first equation to solve for x. Always substitute the value into the linear equation to check for extraneous solutions. So we're not plugging it into the quadratic equation. We always substitute it into the linear equation. So one of the values we got for y was 1. So we're going to plug it into equation 1. So we get x minus 1 equals negative 1. So x minus 1 equals negative 1. If we add 1 to both sides, we get 0. X is equal to 0. And so therefore, the y value is 1, and we got x to be 0. So our ordered pair there is 0, 1. Now we have to substitute y equals 2 into the first equation. So plugging 2 into the first equation, we get x minus 2 equals negative 1. Add 2 to both sides, and now we get x, which is equal to 1. So our x coordinate is 1, and our y coordinate is 2. So the solutions are 1, 2, and 0, 1, which can be verified by substituting these x, y values into both of the original equations. And then if we take a look at figure 3, we have our parabola, y equals x squared plus 1, which is in red. And then we have our linear, x minus y equals negative 1, and it intersects that parabola at 2 points, 0, 1, and 1, 2, which is what we solved for.